We are starting right away with Robert Hensing on NixOps. So take the stage.
Yeah, thank you, thank you. Thank you. Yeah, so I'm Robert. You can see my my socials and whatever here. Robert H mostly on GitHub. That's how most people know me. Yeah, so this talk is about NixOps4. A bit about me. I started using Nix about 9 years ago, I think, and I was so excited about it that I started a company with a little service called Hercules CI. It's CI, and you run it on your own runners, and then it talks to like herculesci.com, and you get a dashboard and stuff. And there's a bunch of other things that I do. I help out with module system maintenance. I'm on the Nix team. I wrote Flake parts. I'm on the steering committee. Yeah, this talk is about NixOps4. If you want to talk to me about modular services, then feel free later. That's yet another thing. But yeah, let's focus on NixOps4. Yeah, so first of all, this is made possible basically by the great people at in the Open Collective. Yeah, when I started doing NixOps maintenance, I realized that it's a pretty big project to get that working well, and I opened this Open Collective. Basically, it's easy to see if there's interest in like funding this kind of thing. That's been running for a couple of years, more than a couple, and that's the whole reason this got rolling. Special thanks also to the Fediversity project. They were instrumental in actually getting NixOps4 started. They provided the sort of activation energy for actually making big changes. So yeah, special thanks to them. Yeah, so what is NixOps4? It's a deployment tool, and it's the successor of NixOps1/2, which 2 isn't quite real. We never really had a release. And in proper NixOps fashion, it is work in progress. Yeah, so a deployment tool. I guess you're all somewhat familiar with Nix. So in Nix, you get... Can I get a cursor on there? Oh, yeah, there it is. Right. Yeah, you write expressions. Those feed into Nix. Then Nix does some nice things with the store, and most of the data goes into the store, but it can also read back from the store. It produces files. Those files contain something. Very often, this is the NixOS activation script, and that makes something cool happen in the real world. So that's just Nix. What makes a deployment tool different? Well, it's basically yeah, doing stuff in these two areas. Nix itself doesn't really do anything there, but a deployment tool is all about it. So NixOps1 is specifically a tool to deploy NixOS systems. It takes care of provisioning and the provisioning of secrets as well, which is a whole topic. And it also has support for deploying other resources, things like DNS entries in a cloud API, or all sorts of other things. Yeah, a number of those were implemented. And yeah, here's a very brief snippet of what that might look like in NixOps1. You have a machine that's a NixOS configuration, which has some special options. NixOps extends NixOS to add those, and that gives it the info to do those cloud things. And the way it works is it first evaluates the resources attribute set, which is at the bottom here. And then it does all of that, and then when that's done, it does all the machines. which is actually not really good enough for some deployments. So that's, I think, one of the reasons, at least for me, why NixOps1 didn't quite succeed. I think other reasons were that it's actually pretty tough to get good testing and CI set up for this kind of project. It's just a whole lot of work, and in this specific project as well, it basically started life as a Python script, and it got improved and improved, but that turns into a pretty big code base. So there's no dates on this. Right, yeah, so this is sort of before some big changes. Then around 2020, I don't know exactly the date, maybe I should have looked it up, but some work was done to alleviate those problems. A plugin architecture was introduced, and now sort of the responsibility for all these parts was distributed as well. This made it really hard to make changes in the core. So and also the tooling got quite heavy, and it was a bit unclear exactly when a pull request was good enough. So yeah, we had some challenges there, and when I joined, well, I didn't really join. I more or less what's the term, succeeded the previous maintainers. I joined because I thought NixOps deserves to have like a good provisioning tool, because when it's integrated, that does really make it easy. When it works really well. And also for my own product, Hercules CI, it needs users to deploy their own stuff. So there's also a bit of a commercial reason there. So yeah, I joined in 2021 to see what I can do. I was able to help with a few PRs, but I couldn't prevent the project from dying. I have kept it mostly buildable most of the time, I think. I might have taken a few reminders, but yeah, not a great success. So yeah, I had to like take a step back and think, like what is it that NixOps should really do? And yeah, I thought back to like before I actually knew what NixOps did. I had this sort of idea that it would be like Nix, but for deployment stuff, and it would be just as great, right? But Nix is designed as a platform, and NixOps was not. It was just a program. So I started making plans and a new architecture. Well, this would be quite familiar if you know Terraform. It looks more like this. On the left, we have still, yeah, I'm making the comparison, right? So instead of Nix, or actually on top of Nix, we have NixOps, and it doesn't produce files, but input values that go into resource operations. I'll get into that in just a second. Those produce output values, and those go back into your expression, and this can happen multiple times. And NixOps knows how to keep track of the data that is relevant to your deployment. Which, it would be great if that wasn't necessary, but in the real world, we kind of have to deal with it. We have to remember some identifiers or other attributes from the things that we create. Right. Architecturally, Nix looks kind of like this. We have this language. It instantiates derivations, and those get built with the store and the sandbox. And what we add to that is another layer, where the Nix language also configures resources. And those resources are programs that are built with derivations. So I think this integrates really nicely. You don't need a special package management solution for resource provider plugins. That's just Nix. So a resource. declares the existence of a real-world object. It's a very common thing to do in software. And it has the CRUD operations, create, read, update, and delete. So that enables NixOps to coordinate things like performing a deployment, updating a deployment. Yeah, so a deployment is just a collection of resources. And that makes it actually quite different from NixOps1. Because in NixOps1, it had this notion of machines and resources, whereas NixOps4 only really knows about resources. The significance of that is that it's actually just as easy to integrate NixOS into NixOps4 as it is to integrate, say, NixDarwin or NixBSD. Those are all on the same level. Right, so operations that NixOps has or will have. The main thing is the apply operation, the big make it so, upsert, whatever you want to call it, which invokes all these CRUD operations. And another thing, it's not implemented yet, but it's actually really low-hanging fruit, I think, is the equivalent of Nix run. It would be really nice if you could just write a script in your deployment expression and then run it, and the script definition could just make references to data about your deployment. So that's definitely coming. It's just not in there yet. Yeah, you could use that to then implement other things, other logic on top of just deployments, which is, for example, backup or key rotation. But it could be anything. If you have some sort of maintenance task, you could just write a script for it and make use of all the identifiers and whatnot that are in your deployment. Right, so I have sort of touched on what resource providers are. So they're built with Nix, called by NixOps, implement a very simple protocol. It's just JSON over standard I/O. Currently, two providers exist. The local one, which is kind of the hello world for deployments. It can execute a command or create a file, which is great for testing and also actually quite useful. And the other one is a big one that I've been working on in the past week or two to get that to work. Is a Terraform adapter, or maybe I shouldn't say Terraform. It's not really OpenTofu either, because it calls the providers directly. So yeah, you could say that this is sort of the third implementation of the Terraform protocol client, technically. Yeah, the way this looks when you're using it is roughly this, right? It's currently Flakes only. I'd be happy to take a PR that makes it not Flakes only, but yeah. In a Flake, it would look like this. It's just a Flake attribute. NixOps4 deployments.default. I think I want to get rid of that, actually. But for now, it's this way. And it contains a function, right? Because the way it works is you have data coming from your resources, going into your expression, and then your expression produces inputs for your resources, and you get this cycle, a fixed point. And what you're declaring here is sort of the user part of that. So for you, the inputs are the resources. Yeah, those contain the output values. And using those, you can then declare what the resources actually are. Yeah, so the current expressions make use of the module system. Module system is technically not required, but currently, yeah, all the things I write at least, they do make use of the module system, which I think is really nice. I think most people would agree. If someone wants to do something else, I would be happy to take a PR to, or even help out with sort of opening that up, making it easier to integrate other ways to do it. But I think for now, the module system is fantastic. So yeah, and instead of having this sort of raw resource declaration where you explicitly provide the provider, you could just import a module. So this is a module from the NixOS input. That should be the NixOps-NixOS input. But yeah, it's from a different repo. This provides an NixOS integration. Yeah, needs SSH and a configuration. And then when you apply this, it'll run the activation script remotely. You can have multiple resources. Here's an example of a resource that requires state. This one doesn't exist yet. And also, the type isn't really a string. But, yeah, so a resource like this, it would generate a key pair, and then it would store both of them or just the public key. And yeah, so that you can use it in later command invocations. And for that, it needs to reference another resource that takes care of actually storing that information. Currently, only one exists, which is the local file state provider. But ideally, you would use something that stores the state remotely, so that if you have coworkers, they see the same information that you see. You typically don't want to commit it, I think, because then you can have branches with different views of the world. Won't work out very well. Yeah, so it's module-based, so you can actually also have like deployment-wide options that you declare and sort of model your deployments in this way. And import, you have all the module system goodies. Yeah, so another thing is also the nesting of expressions, nesting of sub-deployments. So it's possible, for example, to have a deployment that represents, say, a NixOS machine with extras, right? It has some provisioning logic in it with a resource for that. It has the NixOS resource that we just saw. Maybe something for a DNS record. And then you can bundle it up into a deployment module and reference that in a sub-deployment. So you can have multiple hosts in that way. You can build like ever larger structures if you like. On time. Yeah, I think I'll just skip over this a bit. This is a bit of a sales page, I guess. You can ask questions. Right, demo time. Let's see. Ooh. Ooh. Gnome, what are you doing? Let's try that again. Ah, that's better. Yeah, let's clear this. Okay, interesting. Sorry? Oh, yeah, is that? Oh, yeah, it can be done. Oh, yeah, that's much better. All right. So, yeah, let's do it. So, what you can see is, yeah. Oh, this one is a bit. Oh, shortcut's not working. Okay. It's supposed to produce a bit of garbage when you resize. It's optimized for preserving all information, not optimized for being pretty. So yeah, what you're seeing is a little text UI on the bottom and a log at the top. Both are very ugly and verbose and in development, so apologies for that, but you can kind of tell that something is going on, I guess. Yeah, so at the bottom you can sort of see the things that are still active or happening. This should take just over 3 minutes. So yeah, you can see it's now trying to find the host key in the log. Right, so we have these multiple resources, right? The first resource created the VM, and this resource that's currently logging, that's a separate resource that just finds the log and returns the log as its output. at least when it's done with looking for a specific string. Right, yeah, and now it's the NixOS part. So this is the local provider, exec, resource type. Yeah, calling SSH. And
Is this already using the Terraform providers?
yeah. Yeah, because this is a VM in the cloud getting deployed right now. I can show, well, this is copying. I can show what's in the file. Right, so it's a flake. NixOps4 currently contains a Terraform provider. I think I'll move it out, just as NixOS is not part of the core either. Yeah, so it's using flake parts. It's the only thing I can do. I'm sorry, but we do have a function for just creating the attribute yourself. That's all fine. Yeah, down a bit. Yeah, so NixOps4 is in the dev shell here. Oh, and here's the deployment. So yeah, it's a big module. Yeah, one thing you don't see in Terraform, right, is you can actually patch your providers right inside your configuration. I use this for actually implementing the adapter, because I could insert some debug statements to figure out what's going on. Yeah, so declaring that the provider, yeah, just giving it a name basically, so it's easy to reference. Naming it is also important for deletions, right? When you delete something from a deployment, you want it to actually be deleted, but it's not in the deployment anymore. So you kind of need a system for that, which I have to admit is not implemented yet. But yeah, so it's all in there. Oh yeah, also retrieving an AMI. Yeah, and in Terraform, this is a separate. It's not. They don't call it a resource. It's implemented in much of the same way as a resource is, but there it would be called a data source, because its primary purpose is just to retrieve data. And it's a bit different in the life cycle as well, I think.
Evaluation happen like recursively as you create new resources, or do you just evaluate them for and then somehow?
Yeah. So the way evaluation works is it happens in a separate process, just to make sure that you don't lose any data if something were to happen in the evaluator. And yeah, so it talks this similar IPC protocol as the provider protocol. And yeah, it's a bit of a back and forth. So NixOps requests to load a flake, for example, and from the flake it requests to load a specific deployment. And then when the evaluator needs information from NixOps, those would be resource outputs, then it can ask over the IPC. Yeah, this makes sure that you don't have to perform multiple evaluator invocations. It's well integrated in that regard. So I think recursive is an accurate description of how it works.
Right? As you evaluate Nix code, and then you have a resource that you're going to create, and there's some information that only once it's created in the real world you're going to get that, like some ID, for example.
Yeah.
And that then feeds back in, does it feed back into the Nix code and continue evaluating?
Yeah, exactly.
So it's like a back and forth between like applying it in the real world and then feeding back into the ongoing evaluation.
Yeah.
Okay, cool.
Questions? Yeah, I think it's probably a good time for questions. I have something about like the state of. Let's first see whether it completed. Right? Oh, that looks successful. Yeah. It has actually deployed a little HTTP server, but I don't think it's too interesting, so let's just skip that. Yeah, I won't go into these slides specifically, I think. There's a whole lot that can be done still. You're welcome to contribute. I'll try my best and make that possible. Like it's very much in flux. The Terraform provider isn't merged yet, but I'll try to do my best. I should get a matrix room for this, I think. Yeah. Yeah, question time.
I got one question. So resources is like an analogy to like Terraform resources, right?
Yeah, it's basically the same thing. Yeah.
So are resources inherently stateful?
Not inherently, actually. So, for example, the exec resource that I mentioned, it doesn't have a very like fixed format or anything. It doesn't produce state necessarily. Like for any resource, you can imagine just saving whatever it produces to the state file, and that could be useful. But not all resources need that information to be available to do something useful, right? Exec, you can just rerun it, and that's probably fine. Same for file. I think the data source example, that could also just run, but you might want to cache it, right? And then state is quite useful.
So would it be valid to simply call resources impurities and use that as the name instead of resources, or is that not a valid analogy?
They are less pure than pure Nix code, of course, but they are controlled state. So I wouldn't call them impurities. That is a little bit too far. Yeah, they're just stateful. I would just call them stateful. That's good enough. Impure, I think you get into maybe impure derivations or evaluation impurities. This actually builds on flakes. So flakes provides, well, your flake provides a function, and that part is entirely pure. And NixOps just coordinates the information flow that function sees in a controlled way.
Yeah, two small questions. So
Yeah.
first one, did I understand correctly that you basically replaced the Terraform part completely, right, with your own custom code?
Yeah, correct.
Cool. So you implemented the gRPC client, right, inside of NixOps.
Mm-hmm.
Cool. And so that means that the graph evaluation, right, for the resources and the sequential execution is something that you control. Like for if you have a bunch of resources,
Mm-hmm.
and that's also pretty cool. And how did you resolve the persistence part for the state? Because in case of Terraform, you usually store it, right, and they have these connectors to all kind of blob stores, which is pretty nice. Except it doesn't work quite often.
Yeah, so it's a bit different. In Terraform, you get a fixed set, at least in official Terraform, maybe OpenTofu might be different. You get a fixed set of providers that support state handling. In NixOps, that's entirely open. Anyone can write a state provider. Currently, the only implemented one is the local file one. And another significant difference is that instead of just putting the final state in the file, it's actually a log. So you can see the entire history of your deployment in it. And the way that works is it's a series of JSON patches. So it's actually, it's fairly standard. You could just run those and that'll produce the final state for you.
Is there any way to synchronize it between different users? So if you have
so not yet, because currently it's only local file, but that's definitely a goal. So in Terraform, for example, you have S3 as a backend or maybe some databases. And the same could be done for NixOps as well. Yeah.
Okay. And the last question, sorry. It's just very interesting because I tried to write the same thing in Rust and I failed because of the code types part. There is this intermediate library. If you, one of the biggest problems with NixOps deployments when you do that with the null provider is that you have absolutely no clue about the diff because it usually shows you the NixOps DRV file and different hashes. Do you plan to address this part? Because it was pretty annoying.
Yeah, that's a good one. That would be great to solve. I don't see anything stopping anyone from doing that. It's not a high priority for me. But that would definitely be nice. I mean, the information is there, especially so. Yeah, you'd want to store the old derivation path, I suppose. Maybe you need to reinstantiate it. Like if your coworker did the previous evaluation, you don't have the DRV file yet. So maybe you need to also do some evaluation to make that work. And then it needs to be aware of Git. So it could be a bit of a rabbit hole. But that would definitely be very, very valuable, I think. Yeah. Okay. Yeah. Yeah, that's it then, I guess.
All right. Thank you very much.
Thank you.